Everyone is trying to build the so-called airboom for compute, but almost everyone is failing. Why? The core issue is that most treat compute resources like static goods, something you can store and use later, like a house or a car. But compute is actually perishable, more like a fresh apple than a piece of real estate. If you don't use a GPU's cycles right now, that value disappears forever. Imagine a server rack sitting idle, its potential fatting away minute by minute. This misunderstanding is why so many attempts to create a compute-sharing marketplace have struggled. The analogy to airboom simply doesn't fit the reality of how compute resources work. Let's dig deeper. In decentralized compute markets, if a GPU sits idle for even 10 minutes, that value is lost forever. There's no way to recover it. Traditional auction systems are just too slow to keep up with the real-time nature of compute demand. That's why researchers like Zhang et al. Propose a different approach, decoupling price discovery from allocation. By separating the process of finding the right price from actually assigning resources, the system can react instantly. This means no more waiting for slow auctions and no more wasted compute cycles. The key is to treat compute as a perishable good, requiring fast, dynamic allocation. Here's the breakthrough: time minting. Instead of renting a machine in the traditional sense, providers stake collateral to mint time slots. Think of it like putting a coin into a minting machine and getting a ticket for a specific time slot in return. The protocol then posts a continuous price based on current load. No more bidding wars, just an instant, algorithmic price that updates as demand changes. This approach ensures that compute is always allocated efficiently, and providers are incentivized to participate honestly. It's a radical shift from the old model, making the market more fluid and responsive. Now let's talk about matching jobs to resources. The secret sauce is something called CFM, cheapest feasible matching. Instead of complex optimization, this greedy algorithm simply matches jobs to the cheapest available resources that can handle them. It's surprisingly efficient, achieving a 1-to competitive ratio, which means it gets close to the best possible outcome without the need for slow, complicated calculations. Imagine a Pac-Man character eating up the cheapest dots in a line, fast, direct, and effective. This is what makes the system scalable and practical for real-world use. Incentives are crucial for making the system work. Enter the premium sharing pool. Providers who stake early and truthfully are rewarded with a share of the market surplus, essentially, extra earnings for being honest and timely. But if someone tries to game the system by lying or delivering late, they get penalized. The verification layer slashes their stake, ensuring that only truthful, reliable providers benefit. This mechanism keeps the market fair and encourages everyone to play by the rules, creating a healthy, self-sustaining ecosystem. This is the theoretical foundation the industry has been waiting for. We're moving away from the old model of renting boxes, think shipping containers full of servers, to a new paradigm, streaming liquid compute. Imagine a digital river of compute power flowing directly into where it's needed, instantly and efficiently. The Gensyn protocol sits at the heart of this transformation, enabling a future where compute is as flexible and dynamic as the applications that depend on it. It's a bold vision, but one that's rapidly becoming reality.